Good afternoon, students. Now I am going to again revise your topic complex analysis. I'm going to again start here actually the complex analysis. Here, students, we know very well. Suppose we have an equation. This is quadratic equation. We have x square plus 1 is equal 0. Okay, so can we write it 1 into x square plus 0 into x plus 1 is equal 0. Okay, suppose this is your equation number first, and we know that what is the general quadratic equation. It's a ax square plus bx plus c is equal 0. So from equation first and second, I am asking to you what is the value of a. This is 1, b is 0 and c is 1. So what is the discriminant right now? The discriminant is d is equal b square minus 4ac. This thing, if you put 0 here minus, I have to introduce the complex number, but before complex number I want to introduce some concept. So this is minus 4 into a is 1 into c is also 1. So means we are getting d is equal, it's a 0 and 0 minus 4, so this means it is minus 4, which is less than 0. So here the roots are number first, they are negative. Here the roots are negative, we can write here. Okay, and now it's a third property. Actually you have studied before about when the d is greater than 0, the roots are unequal and real, but when d is equal 0 means roots are equal and real, but d is less than 0. Now right now you are in class 11th, but in class 10th your teacher neglect it. They have not introduced this thing, because you have to introduce by the teacher in the class of 11th. Okay, so in the same class I am introducing it. So students, it's here the roots are negative. Now I want to find out here the roots. So we know by dharachar x is what? Minus b plus minus under root b square minus 4ac upon 2a. So let us see here what is the value of x now. It's a minus b is already 0 plus under root, we are getting here the already b square minus 4ac we are already having, it's a minus 4 upon 2 into a is 1. So this means we have a x is root of minus 4 upon 2, or we can write this portion minus 1 into 2 to the whole square upon 2. So this will give you x or 2 root minus 1 upon 2. So here students, we are getting the value x is what? Root minus 1. This is what? This is square root of, I am writing here, square root of any negative number. So we can't solve it, we can't solve this portion. Okay, this thing is what? This is known as a imaginary number. Okay, according to the some mathematician, they are not able to find out the value of this root minus 1. So they have thought, means the first image, it's called imaginary number, means I is equal root minus 1. And who discovered it? It's an Italian mathematician here. The who found, you can say who founded it here. Imaginary, this is called the imaginary number. Imaginary number developed by Italian mathematician. He was Italian mathematician. Of course, this is not a board question, but you should need to know. Italian mathematician. What is the name? Name is Girolamo. Girolamo and Cardano. This is the name. Okay, so in this way, some here the mathematician, Italian mathematician, discovered this number, this so-called imaginary number. Okay, so now I am going to solve here some questions. Here we know that I is, finally the value of I is root of minus 1. So squaring both sides, on squaring both sides, we have I to the whole square is equal root of minus 1 to the whole square. So this means we have I square is equal minus 1. Now I am going to solve some questions here. Suppose I am asking to you what is the value of I3. Okay, so this means I3 is what, we can write it I to the power 2 into I, because in the multiplication the power will be add. Here the power is what? 1. There is power 1. So 2 plus 1 means I, it will be 3. So but we don't know the value of I. We have a value of I square. I square is minus 1 into I. So this will give you minus I. Okay, suppose I am taking here the next value, I to the power 8. So can we write it I to the power 2? It's your issue. How will you write it? I to the power 4. Can we write 2 4 is 8 actually? So I square, we have a minus 1 to the power 4, and this will give you what? Minus 1 into minus 1 into minus 1 into minus 1 means it is plus 1. Okay, suppose I am taking here the I to the power. Okay, now I am taking the third point, I to the power 19. Okay, so I to the power 19 is what? Can we write it I to the power 2 to the 9? Okay, I to the power 2 into 9 into I. This means I square is what? I square here is minus 1, and minus 1 to the power 9, it's an odd number, into I. Okay, actually 2 9 is 18, and 18, and here the power is 1, so because of this it will be the exponents are 19 here. So it is I to the power minus 1 to the power 9 is what? It's a minus 1 into I, and the answer is minus I. Is it clear, students? The concept is completed. Okay, now I am going to explain here the definition of the complex number. See the definition of complex number. A number which can be written in the form of a plus ib. Okay, a number which can be written in the form of a plus ib, where a and b are real number and I is a complex number, imaginary number. Okay, and we will represent complex number by z. Okay, suppose that I am taking here the a plus I b. This is, of course, this is a complex number. Okay, where a comma b belongs to R, means a and b are real number, and I is of course imaginary number. Okay, and what is the value of I? I is root of -1. So students, here a is what is the value of a? This is called the real part of, actually it's the real, here is not involved any imaginary. Okay, so real, this is called the real part of z, and b is what? This is called the imaginary part of z. Okay, any problem, students? So this is the main definition of the complex number. If you want to write, you can write. Now see the geometrical representation of a complex number, where you will locate a complex number. This is an issue. Yes, okay. Geometrical, you can say the representation of a complex number. Here the representation of a complex number. How will you represent a complex number? You can say the geometrical representation. Okay, geometrical complex number. We know very well here, suppose if you are talking about the Cartesian plane, here suppose it's a horizontal vertical line, and here is a horizontal line. I am taking this distance up from origin to this point A is small x, and here I am taking the distance, it's a by. Okay, so this means the coordinate I am taking at this point, what is the coordinate? It's x comma y, which is in ordered pair. Okay, so students, this thing we are representing in the Cartesian plane, but if you write, if you want to we will represent complex number on Argand plane, ARGAND, Argand plane. Okay, so the here is the coordinate of this point are x comma y. So the associated complex number by this point is what? X plus I by. Okay, and if here the actually the it is this number, this point is located in the first quadrant, where the x distances and y distance both are the positive. Okay, so I am going to give you some points here. Suppose I am asking to you, of course this is now not a Cartesian, it's a Argand plane, it's a Argand plane. Okay, because every time if you represent complex number, you will represent on the Argand plane. So suppose I am taking here the coordinate 2 comma 3. So this means the complex number associated by this point P, the complex number is what? The associated complex number is what? Complex number is what? 2 plus 3i. Actually two is this is the real part of actually you can say this is the real part of z, and it's this is this because of this line is called imaginary line. Okay, this line is also known as a imaginary line. Okay, yes. So here the 3 is what? It's a imaginary part of z. Here it's a 2, and here the 3. The distance is for the y-axis. Because of this, the y-axis, line, you can say this line is a imaginary line, and it's a imaginary part of z. Okay, here 2 is what? Real part of z. I will write in this way, and 3 is what? Imaginary part of z. Okay, students, now see more. here is the point, its coordinate I am taking minus 6 comma suppose it's a minus 6 comma 7. So associated complex number we know very well, it's z is equal, every time actually we can represent the complex number by z. Okay, because of this I am again and again writing z. It's a minus 6 plus 7i. Okay, and one more I want to give you here, means if you have a Cartesian plane, that means you can convert the plane in Argand plane by associated complex number. Okay, so suppose that here I am taking the number minus 5 comma minus 6, so this means it will give you the complex number minus 5 minus 6i. Suppose the fourth quadrant, actually here the signs are negative because this point lie on the third quadrant. If it is lie on the fourth quadrant, here x will be positive, means 5, and here I am taking y is minus 4. So the associated complex number is, we can locate the complex number here, you can locate this point here, it's a minus 5 minus zi. So this is, of course this is, sorry, it's the I, so this means it's a complex number and we can represent complex number on a Argand plane. Okay, here you can write it 2 plus 3i, this point you can write it minus 6 plus 7i, and here you know very well it's a, here will be 5 minus 4i. Okay, everything is clear, students? Now I am on the next part, and this is very important part. Now listen, I want to give you some questions to you here. Suppose here we have a question, let, I am taking here the question, let x plus I by is equal 5 plus 3i. Of course this is a complex number and it is also a complex number. Here if two complex number are equal, then their real part, if you can write here, if two complex number are equal, then their real part of z and imaginary part of z are also equal in each other. Is it clear? Means the real part of this complex number is what? X. That means that will be equal for real part of next complex number, it will 5. And if here is the imaginary part of z, I am asking to you what is the imaginary part of z, this will by, and here will be what is the imaginary part of z, this is 3. In this way you can find out the value of x and by. Okay, suppose if you have a new other question, suppose let here 1 upon 5 minus 3i, and we have to convert it in form of a plus ib, means we have to convert this number, okay, in which form? A plus ib. So how will you convert it? Of course this will be a complex number, so let us suppose z is equal, but it is not in form of a plus ib, this number is not in form of a plus ib. So can we we can write 5 minus 3i, can we rationalize it? Of course we can. It's a 5 minus 3i, denominator is, so here will be numerator we will multiply 5 plus 3i, and of course in denominator we will multiply 5 plus 3i. Okay, so now students, 1 multiply with the 5 plus 3i, this is 5 plus 3i, and now student, this thing, it's a minus b, and here is a plus b, means we can write it 5 to the whole square and minus actually a square minus b square, we will apply 3i to the whole square. So this thing you will get a 5 plus 3i upon, it's a 5 to the whole square, 25. And student, this portion is very important. Many students do a mistake have done here the mistake. Actually 3 to the I means it will be 9I to the power 2. Okay, 9I to the power 2. So here we will get a 5 plus 3I upon 25 minus, and 9 into I square is what? Minus 1. So this will 9 into minus 1 minus 9. We have 5 plus 3I and 25, and now minus multiply with the minus, this will plus 9. So finally we have a 5 plus 3I, but we are not getting a number in form of a plus ib. But how will you represent? So students, here you can say we have to represent in form of a plus ib. So a, can we write it 5 upon 34 plus 3I upon 34? Of course this is in form of a plus ib. Real part of z is what? 5 plus 3 5 upon 34, and imaginary part of z is 3 upon 34. Is it clear? Okay. So students, I am going to start the concept related to polar representation of a complex number. This is very important. Now students, see here, its origin, it's the x and y-axis. Suppose here is a point, and the coordinate of this point I am taking x comma y, means associated complex number is what? It is x plus iy. Okay, so students, one thing more I want to tell you here, this distance, if you are taking, this is y, and of course this is x, and this portion will give you the modulus. Okay, suppose for some times I am taking here it's a r, and the angle is theta. Okay, so will you tell me what is the value of sin theta? Sin theta is in this triangle, it's a 90-degree angle. What is the value of sin theta? What is the value of sin theta here? Sin theta is perpendicular upon hypotenuse. This is pi upon r. Okay, here OP is, I am taking r. This will give you the modulus actually. Okay, so pi is what? Here, from here you can get pi is r sin theta, and cos theta is what? Cos theta is base upon hypotenuse. So base is x upon r. So x is r cos theta. Okay, we have now both the numbers. So we can represent a complex number z is x plus iy. So z is equal, what is the value of x? This is r cos theta plus I into y is what? R sin theta. If you are taking r as a common, we have a cos theta plus I sin theta, and this is polar form. This is what? This is polar form of a complex number. Okay, here. Okay, so students, from equation first, and this is equation number second. Okay, so squaring both the side in those equation, I am going to square both equation. So from equation first and second, we can see from the equation first, if you are squaring this portion, I want to square this equation first. So x square is what? R square cos square theta, and this is what? Y square is equal r square sin theta. I will tell you why I am doing it. So x square is, now this is suppose equation number 3, and here is equation number 4. Okay, so now students, adding both the equation, if you add both the equation, you will get what? X square plus LHS will be added with the LHS side, and RHS side will be added with the RHS side, means r square cos square theta plus r square sin square theta. What is common? R square is common here. This thing, it's a cos square theta plus sin square theta. Okay, it's x square plus y square. So here we are getting r square into cos square theta into plus sin square theta is 1, So x square plus pi square is r square, means r square, the value of r square is x square plus pi square. Okay, so this r, if I am asking to you what is the r is root of x square plus pi square. This is called a modulus. This is what? Modulus of z, or you can write modulus of z is equal r is equal root x square plus pi square, in this way. Okay, from the question you will every time get the value of modulus very simply, but the main matter is about argument. The very important part is argument. It's not an easy task for every student. Okay, so modulus is clear. Now I am working on the argument. I will work here. So for the argument here, what is argument? Again and again. Argument is what? The angle whatever we have taken from here, this theta. Okay, and here the coordinates are x comma y. Okay, so the argument is what? The angle theta is called amplitude. It can be also speak amplitude or argument of z. Okay, so normally if your point lie on this quadrant, I am asking to you angle for, we have to find out the angle theta, means this is, of course, this is pi and here is x, this distance we have taken the pi and x. Okay, so I am asking to you what is the value of tan theta. Tan theta is pi upon x. Okay, and theta is what? It's a tan inverse pi upon x. Okay, here you can see here tan inverse pi is what? What is the value of pi? Pi is what? From the x plus I pi is what? This is what? Imaginary part of z. This is imaginary part of z upon x is real part of z. If theta is if the point is lie on the first quadrant, then you can find out the argument very easily. But student, the matter is what? The matter is that every time I'm making here some figures. If theta is lying here, okay, if point P is lie in the first quadrant, so angle is here theta. Of course we know very well. If point is lie at this particular point, it's a figure 1, and here is I am taking the figure 2. If point, suppose here is the point, the coordinate of this points are x comma y, and it is lie in the second quadrant, then the angle actually we will count from the x-axis, positive direction of x-axis, it will be theta. Is it clear? And if the point is lie on the third quadrant r, okay, the coordinate x comma y, then if you join this and with the origin, so the angle from the x-axis direction, it's a theta here. And for if point S is lie on the fourth quadrant, then the angle of theta is this. Okay, so this is figure 3 and here is figure 4. Is it clear? If I am asking to you the argument at this point, angle is at this point is what? So you will you have many replies. Of course from here it's a theta, but after, if you complete this rotation, and it will be 360. Of course from here to here this is 360, and 360 plus theta, so there are second angle we are getting. And again we are it's a 2 pi plus theta, and now it is 4 pi plus theta. So we are getting the many angles, but we need to find out here the theta, which is the argument. But we have to work on the here. This thing is very important, which I want to tell you here. Here we need to find out principal argument, not a only theta. We don't need only the theta, we need to principal theta. Means here we don't, I am writing here the very important step. We don't need, actually we are applying this condition because we are getting many angles for this point. For this point we are getting many angles. If I am asking to you, suppose for this point you are getting only one angle, no, you will get a many angles. Suppose it's a 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, 8 pi plus theta. This means, so we have a condition. We don't need here we don't need here to find only argument, but we need to find principal argument. And now what is the principal argument? If theta, very important line, if theta is lying between, you can say in this way, I am applying here the open interval minus pi comma pi close interval. Okay, if theta is lying between minus pi to pi, then it is called principal argument. Okay, so we have to work in the complex number only for the principal argument. And here I will explain this portion more. Here theta should be belongs to, here theta is this pi, it is not, it's a minus pi is less than theta, is less than or equal pi. So you can write this in this interval form. Minus, it's open interval, but here is closed interval due to equality. Okay, so we have to count angle. It's, of course, this is 0 degree, here is pi, so positive pi, but here it's for the negative direction, for anti-clockwise direction it will be minus pi. Means we had to work from here to here. We can find out here to here argument from here to here, only this portion. You can see the minus 180 to plus 180 or equal 180. Okay, so I will discuss